Hello, in this video I'm going to walk you through the pre-lab basically of Millikan's oil drop experiment and just give you an idea of what sort of expectations there are for you. So to get right into it, the objective of this lab is going to be, and it is a Gedanken, I am telling you that, to determine the number of excess electrons that are on an oil drop. Now you have to understand, if we were going to do this experiment in real life, we'd have to have equipment like what you see off to the right there. This kind of silverish kind of thing here, that's what actually contains the parallel plates that would be used. Here's the scope that would let us look into there to see the oil drops that are floating. Here's our atomizer and mineral oil. Everything else is all about getting things set up so that it would have the right voltages and things like that. But this piece of equipment is actually really expensive. And you may recall in class when I described the Millikan oil drop experiment and that I did it in university, even knowing what you're looking for, it is very difficult to collect data. So we're just doing it as a Gedanken, where we're going to supply data for you. And we are very definitely doing something in the way that we're rigging it for you in the Gedanken that wouldn't happen at all in real life. We are going to give you a set of data where all of the oil drops involved actually do have the same number of excess electrons. You'll remember that in the classic Millikan experiment in real life, you would have a whole bunch of oil drops, but one of them might have 17 excess electrons and another one would have 3 and another one 20, whatever, we don't know. But we're telling you that somehow we've actually kind of filtered out the data for you so that we're asking you just to look at a set of data where all of the oil drops have the same number of electrons, excess electrons, I should say. Now, keep in mind for your hypothesis, you have absolutely no way of predicting the actual number of excess electrons on your oil drop. It's not like you can make up a number like 7 and it means anything. There's anything to that. So you cannot just make up a number. But what you can say is something about what you expect is possible for the kind of answer you have. Think back to the way that we talked about Millikan when we were talking about how he had to handle his data and the one thing that he knew was true about every oil drop he was looking at. You also have to show me some basic physics formulas as they appear on your data sheet that eventually you'll be combining and manipulating in your analysis. Don't show any of that here, though. This is your hypothesis. You don't show any of that here. And when you're trying to figure out your controlled, manipulating, and responding variables, first of all, look at the data that you're supplied in the observations. We get to do a little bit of a cheat here because we're giving it to you. But take a look at that, because that aims you right in on what your manipulated and responding variables are. And then you can look at everything else that's in your formulas and even the way that you're going to be combining them eventually in analysis. And you should be able to tell me what your controls are then. Now, for equipment and procedure, please write this up, as always for a Gedanken, with sort of that, pretend that we're doing, that you're actually doing the lab. Think back to the way that I described how Millikan did the experiment. I showed you that diagram. We went through what each piece of the equipment was, and then I described to you how he was actually doing the experiment and collecting his data. That's what you're going to do for the equipment and the procedure sections. Now, you do have a pre-lab question I'm asking you to look at, and that's that in Millikan's time, he would have had just, a whole bunch of data that he was always collecting, and he had no way to use a computer to try to easily sort or filter that out. So what I want you to look at is explain how this was a disadvantage to him and how it meant he had to approach looking at the data that he did collect. So for the observation section, you do have to open up the manual for this, the lab manual, and take a look in there because there are 4 different sets of data. you are only responsible for doing one set of data. If you also look on the Google Classroom for this lab assignment, you'll see that what I've done is broken it down by last names. So just look at the letter of your surname, and it'll tell you which set of data you are responsible for doing your observations and then analysis from. So for the analysis, you're going to have to show me how you play around with all these formulas and get it into some sort of a format where you can actually say, hey, I'm going to graph something, something, something as a function of something. This needs to be done so that you're getting a value for Q, because if you're able to get Q, just like we did in the notes, then you can figure out how many excess electrons you've got. You do need to show me all of this. And remember, I know that typing out formulas and things can be a bit of a task, so you are perfectly welcome to handwrite this all on a piece of paper as your discussion, your explanation portion of what's happening in your analysis. At some point, you're going to have to take these numbers, though, get them into your calculator, and do a linear regression on there. Please make sure that you do show me first the unrounded values for your slope and y-intercept so that I know that you did your graph correctly. And then you're going to have to use that slope in order to get the value for the charge, number of charges, excess charges, I have to keep correcting myself, on your oil drop. And you do have to get to the point here where you have rounded this off to the nearest whole number multiple that is a reasonable answer. In the error section, you do need to figure out, comparing the number you just rounded off to the rounded off value, what your error is, because that does say something about, that little bit of fluctuation in the data that must have caused you to not get exactly a whole number. And then also try to discuss, a few sources of error that are reasonable for how some problems can occur with this experiment. And again, kind of think back on the way I was describing the difficulties that surround doing that lab. Finally, for your conclusion, just a good old-fashioned sort of conclusion. You do have to make sure you are making a statement as a whole number of the number of excess electrons that your oil drop had, and then you're pretty much done. I hope this helps you out, and good luck with your lab report.